Welcome back to week 2. Last week we learned the fundamentals, variables, constants, operators, and wrote our first emission calculations. This week we go deeper. We'll explore PHP's data type system and understand how different types of environmental data are represented in code. Then we'll master strings, the backbone of report generation. By the end of today, you'll be able to take raw sensor data, messy, unformatted text and numbers, and transform it into clean, professional carbon footprint reports. This is exactly what the reporting layer of our CarbonTrack platform will do. Here's our roadmap. Hour 1 focuses on data types, how PHP represents different kinds of information. We'll work with environmental sensor data to make it concrete. Hour 2 is all about strings, text manipulation, which is essential for generating reports and cleaning messy data. Hour 3 is hands-on. You'll build an energy tracking receipt that combines everything. Each hour builds directly on the previous one, and by the end, you'll have a complete script that processes raw device data into a professional emission report. Let's quickly recall where we are. Last week you learned to store data in variables, define constants, do arithmetic, and format output. You wrote your first emission calculations. But we glossed over an important question. What type of data are we working with? When a sensor sends 15,000, is that a number or text? What happens when you try to multiply text? How does PHP handle these situations? And once we have our calculated values, how do we turn them into clean, readable reports? Those are the questions we answer today. In the real world, environmental data is messy. Sensors send strings, not numbers. CSV files have formatted numbers with commas. User forms return everything as text. Some fields are empty, some have garbage values. If your platform doesn't handle types correctly, you get wrong calculations. Imagine a carbon report that's off by a factor of 1,000 because someone confused kilograms with tons, or a sensor reading was treated as text instead of a number. Data type awareness isn't academic. It's the foundation of data integrity. Our CarbonTrack platform must handle every edge case correctly, and that starts with understanding PHP's type system. PHP has 8 data types organized into 3 categories. Today we focus on the 4 scalar types and null. Scalar means single value, 1 integer, 1 float, 1 string, 1 boolean. Compound types hold multiple values. Arrays and objects come later in the course. PHP is dynamically typed, which means a variable can hold an integer now and a string later. You don't declare types up front like in Java or TypeScript. This flexibility is both a strength and a danger. It makes coding faster, but can hide bugs. Modern PHP gives us tools to add type safety when we want it, and we'll use those tools in our platform. Floats are decimal numbers, and they're the most common data type in environmental monitoring. Energy consumption is almost always a float. 12.5 kilowatt hours, not a round number. Emission factors are floats, 0.47, 2.02, 2.68. Sensor readings like temperature and humidity are floats. Even calculated results are floats because multiplying a float by a float gives a float. In our CarbonTrack platform, the majority of data in the emission and values, activity data, emission factors, and calculated CO2e, all floats. Get comfortable with them because you'll be working with them every single week of this course. This is probably the most important warning in this entire course about data types. Floats are not perfectly precise. When you add 0.1 and 0.2, you don't get exactly 0.3. You get 0.30000000000000004. This is not a PHP bug. It happens in every programming language because computers store numbers in binary, and many decimal fractions can't be represented exactly in binary. It's like how 1/3 is 0.333 repeating in decimal. You can never write it exactly. For our platform, this means never compare floats with double equals. Always use a threshold-based comparison, and always round values before displaying them. In professional carbon accounting, results are typically reported to 2 to 4 decimal places, so round is your best friend. Integers are whole numbers, no decimal point. In our GreenTech context, integers represent things you can count. The number of devices, the number of sensors, database IDs, years. You don't have 3.5 devices, you have 3 or 4. Integers are also used for IDs because every record in a database gets a unique whole number identifier. An interesting PHP behavior. When you divide two integers, if the result is a whole number, PHP returns an integer. But if it's not evenly divisible, PHP automatically returns a float. So 10 divided by 2 gives integer 5, but 10 divided by 3 gives float 3.333. This automatic conversion is part of PHP's type juggling, which we'll explore shortly. Booleans are the simplest type, just true or false. In a GreenTech monitoring system, they're everywhere. Is this device active? Is the sensor online? Is maintenance mode enabled? Has the calibration expired? Each of these is a yes-no question, making Boolean the perfect type. Booleans also result from comparison operations. If the temperature is 45.5 and we check if it's over 40, we get true. We can store that Boolean and use it later for alerts or display. The ternary operator, that question mark : syntax, is a compact way to output different text based on a Boolean. We'll use Booleans extensively in our platform for entry status checks, user permission flags, and device monitoring states. Strings are text values, and in a reporting platform, text is everywhere. Device names, brand names, locations, serial numbers, scope labels, categories, status codes, reporting periods, timestamps, all strings. Notice how strings can contain structured information. The device code SM-BLDA-F3-001 encodes the device type, building, floor, and unit number into a single string. Later today, we'll learn how to extract these parts using string functions. In our database, varchar and text columns store string data, and we'll validate and clean strings before storing them. A string that looks clean on screen might have hidden spaces, wrong capitalization, or invalid characters. We'll learn to handle all of that in Hour 2. Null is one of the most misunderstood types, but in environmental monitoring it's critical. Null means no value, not zero, not empty, just nothing. Here's why it matters. If an energy meter reads 0.0 kilowatt hours, it means the device measured zero consumption. Maybe the building was shut down for the weekend. That's valid data. But if the sensor is offline and returns null, it means we have no data. We don't know what the consumption was. These are completely different situations. If your platform treats null as zero, you'd underreport emissions during sensor outages. In our database, nullable columns allow null values for optional fields. Always use isNull or strict comparison = null to check, and never confuse null with zero or empty string. PHP provides isInt, isFloat, isString, isStringed, isNull, and isNumeric to check the tension of the new video and treble. PHP provides isInt, isString to check types. The getType function returns the type name as a string. One thing to notice, PHP internally calls floats double, legacy naming from C language. These functions are essential for data validation. When sensor data arrives, we need to verify it's the right type before calculating. IsNumeric is particularly useful. It checks if a string can be treated as a number. 15,000 passes, but 15,000 with a comma fails, and 12.5 kilowatt hours with a unit suffix fails. This tells us what cleanup is needed before we can do math. We'll build validation functions that use these checks extensively. Type juggling is PHP's automatic type conversion. When you multiply a string by a float, PHP converts the string to a number first. When you concatenate a number with a string, PHP converts the number to a string. When you use a value in an if statement, PHP converts it to Boolean. This is convenient. You don't need to manually convert sensor data from string to number before calculating. But it can be dangerous. Look at the last two examples. 10 devices plus 5 gives 15, because PHP takes the leading number 10. But devices 10 plus 5 gives just 5, because there's no leading number, so the string becomes 0. This silent, unexpected behavior is why explicit validation is crucial. Don't rely on type juggling for critical calculations. Always validate and cast explicitly. This is one of PHP's biggest gotchas. The string 0 is falsy. It evaluates to false in Boolean context. But 0 is a perfectly valid sensor reading. If a power meter reads 0 kilowatt hours, meaning the building used no electricity, that's real data. But a naive if check would treat it as no data. This is a real bug that has affected production systems. The same trap exists with the integer 0 and float 0.0. The correct approach is to use explicit checks. Value dleb.null and value dleb.dollar to check if data exists, regardless of whether the value is 0. For our Carbon Track platform, we'll build validation functions that handle these edge cases correctly. This slide alone can save you days of debugging. Loose comparison with double equals converts types before comparing, and the results are bizarre. 0 equals the string offline? Yes, because offline gets converted to 0 in numeric context. 0 equals null? Yes. 0 equals empty string? Yes. These are not bugs. This is how PHP's type juggling works with loose comparison. The solution is simple. Always use triple equals for strict comparison. It checks both type and value, so integer 0 is not equal to string offline. In our platform, we'll establish a coding standard. Strict comparison everywhere, no exceptions. This single rule prevents an entire category of bugs. Typecasting is explicit. You tell PHP to convert a value to a specific type. Put the target type in parentheses. Int, float, string, bool. This is safer than relying on automatic juggling because you're in control. But there are edge cases to know. Casting 42 ABC to int gives 42. PHP takes leading digits and ignores the rest. Casting 9.99 to int gives 9. It truncates, not rounds. Always use round if you want mathematical rounding. The pattern at the bottom is what we'll use in our platform. First trim whitespace, then check if it's numeric, then cast. This three-step approach, clean, validate, convert, prevents bad data from entering our calculations. This is a realistic example of processing sensor data. Everything arrives as strings, from HTTP requests, CSV files, APIs, databases. We process each field according to its expected type. IDs become integers, measurements become floats, flags become booleans, names get trimmed. Notice the question mark operator for notes. If the empty string is falsy, we convert it to null. This is a design decision. In our platform, we'll store null for missing optional fields, not empty strings. The output loop uses var export, which shows values in a data which released in the registrative type. The pendum parsable format, useful for debugging. This processing pattern is exactly what our Carbon Track controllers will do when receiving form data. This slide shows a complete data structure for an environmental monitoring device using all the types we've learned. Integers for IDs and counts. Strings for names, serial numbers, locations, and dates. Booleans for status flags. Floats for measurements and calculations. Null for optional fields without data. Notice that dates are stored as strings. PHP has a special datetime class we'll learn in week 14, but for now, formatted strings work fine. This structure mirrors what a row in our emission sources and emission entries tables will look like. Every field has a deliberate type choice. This is data modeling, deciding what type best represents each piece of information. Take 5 minutes for this exercise. Process each field in the raw array. For device ID, verify it's numeric, then cast to int. For temperature and kilodouble hour or reason, trim first, verify numeric, and then get the device aim. For device name, just trim. For error code, it's empty, convert to null. The bonus question is tricky. Bool true, true, but not because PHP understands the word true. It's because any non-empty string is truthy. So bool false also gives true. If you need to handle string booleans, you'd use filter var, filter var. This is a real-world gotcha when processing API data. Let's recap hour 1. You now understand PHP's type system through the lens of environmental data. Floats for measurements, integers for counts, booleans for flags, strings for text, null for missing data. You know that type juggling can be dangerous and that strict comparison prevents a whole category of bugs. Most importantly, you understand that 0, null, and empty string are 3 completely different things in environmental monitoring. A sensor reading 0 is real data. A null sensor is offline. An empty string is probably a form field that wasn't filled in. Getting these distinctions right is what separates a reliable platform from a buggy one. Now let's learn strings, the tool for turning all this data into human-readable reports. Every single piece of text your users see is a string that was built by your code. The labels, the formatted numbers, the status badges, the alert messages, the log entries, all strings. And the raw data they're built from is messy. Sensor names with extra spaces, inconsistent capitalization, numbers that need formatting, IDs that need parsing. String processing is what transforms raw data into information. In a GHG reporting platform, the quality of your text output directly affects usability and trust. A report with inconsistent formatting, wrong capitalizations, or garbled text undermines confidence in the numbers. Let's learn to build clean, professional output. Single-quoted strings are literal. PHP doesn't process anything inside them. Variable names are printed as is. $name appears as the text $name, not the variable's value. Escape sequences like \n are printed literally too. The only exceptions are plus, to include a literal quote, and plus for a literal backslash. Single quotes are ideal when you want exact text, SQL queries, file paths, regex patterns. They're also marginally faster since PHP doesn't need to scan for variables or escape sequences. In our platform, we'll use single quotes for string constants, array keys, and any text that doesn't need variable substitution. Double-quoted strings are dynamic. PHP scans them for variables and replaces them with values. This is called string interpolation. It's extremely convenient for building output. You write the template text with variable names embedded, and PHP fills in the values. Escape sequences like \n for new line and \t for tab also work only in double quotes. There's an important gotcha. If a variable name is followed by a valid identifier character like underscore, PHP gets confused. Scope $scope_total looks for a variable called $scope_total. Use curly braces to be explicit. Scope $scope_total. Always use curly braces when the context is ambiguous. It's clearer and safer. The dot operator is PHP's string concatenation operator. It joins two strings together. The dot equals operator appends to an existing string, which is how we build multi-line output. This pattern, start with an empty string, append line by line, is fundamental for report generation. Each line adds one piece of information. Notice how we mix interpolation and concatenation. The concatenation assignment appends the formatted line, and within each line, variables are interpolated. We also use str_repeat to create a line of repeated characters for visual separators. This is exactly how our Carbon Track report generator will build text output, accumulating formatted lines into a complete report string. When should you use interpolation versus concatenation? Use interpolation when you're embedding simple variables into text. It's cleaner and easier to read. Use concatenation when you need to include function calls or complex expressions because you can't put function calls inside double-quoted strings. The best practice is a hybrid. Calculate complex values into simple variables first, then use interpolation. Compare the bad and good examples. Same output, but the good version is much easier to read and maintain. In a team project, readability matters more than saving a line of code. We'll follow this pattern consistently in our Carbon Track templates. Haridoc syntax is perfect for multi-line text templates. You start with 3 less than signs and an identifier. I use report here, but you can use any name. Everything between the opening and closing identifier is a string with interpolation, just like double quotes. The big advantage is you don't need to escape quotes, and the multi-line formatting is preserved exactly as you write it. For our GHG platform, Haridocs are ideal for building formatted text reports, email notification bodies, and log messages. Notice how the closing identifier can be indented in modern PHP. The content will be de-indented to match. This produces clean, aligned output without messy concatenation. NowDoc is the single-quoted version of Haridoc. The identifier is wrapped in single quotes, and nothing inside is processed. No variable interpolation, no escape sequences. It's purely literal text. This is perfect for SQL queries where you don't want $ signs or backslashes to be interpreted. regular expressions with lots of special characters, and code examples and documentation. In our platform, we'll use NowDoc for SQL query templates, and then pass parameters separately through PDO prepared statements for security. The distinction is simple. HairDoc when you need variables inserted, NowDoc when you need exact literal text. Escape sequences let you include special characters in double-quoted strings. The most common are \n for new line, \t for tab, / for a literal /, and / for a literal double quote. In our platform, we'll use \t for tab-separated values in CSV exports, \n for multi-line log messages and reports. The / escape is important for Windows file paths, and / prevents variable interpolation when you literally want a $sign in your text. Remember, these only work in double quotes and HereDocs. In single quotes, \n is literally the characters / and n. Trim removes white space from both ends of a string. Spaces, tabs, new lines, carriage returns. This is one of the most important functions for data processing. Real-world data is messy. Sensors add trailing new lines, CSV parsers leave spaces, users type extra spaces. If you don't trim, comparisons break. Look at the last example. Scope 1 with a trailing space does not equal Scope 1. The comparison returns false. This could cause your platform to misclassify an entire emission entry. In our Carbon Track platform, every piece of user input and sensor data should be trimmed before processing. It's the first step in our clean, validate, convert pipeline. Data arrives in inconsistent formats, sometimes all caps, sometimes lowercase, sometimes mixed. Case conversion functions fix this. str to lower converts everything to lowercase, ideal for storage and comparison. str to upper makes everything uppercase, good for headers and labels. uc first capitalizes just the first letter, perfect for status displays where draft becomes draft. UC words capitalizes the first letter of each word, turning building a floor 3 into building a floor 3. The pattern at the bottom is common trim, lowercase, then capitalize properly. This 3-step normalization ensures consistent data. For comparisons, always convert both sides to the same case. Scope 1 and Scope 1 should match. String returns the length of a string, essential for validation. In our platform, device names must be at least 3 characters and no more than 255. PHP 8 introduced 3 elegant search functions: stir contains, stir starts with, and stir ends with. These return booleans and are very readable. Before PHP 8 we used position or false. Notice the strict comparison is not equal to false because position 0 is falsy. If the substring is at the very beginning, substring 0, which loose comparison would treat as false. This is another reason to always use strict comparison. Substr count counts how many times a substring appears, useful for analyzing data patterns. Substr extracts a portion of a string. The first argument is the string, second is the starting position, 0 indexed, and the optional third is the length to extract. If you omit the length, it takes everything from the start position to the end. Negative start values count from the end. Substr, $* minus 3, gives the last 3 characters, useful for extracting file extensions. We'll use substr extensively in our platform, parsing reporting periods into year and quarter, extracting components from serial numbers, parsing date strings into date and time parts. This is the foundation of structured data extraction from text. In later weeks, we'll use more powerful techniques like regular expressions, but substr handles most common cases efficiently. str-replace finds a substring and replaces it with another. This is incredibly useful for data cleaning. Sensors might send 12.5 kilowatt hours. We need to strip the unit before calculating. CSV files might have formatted numbers with commas. We need to remove them. Labels might use spaces where we need underscores. The array version is powerful. You can replace multiple patterns in one call. The template example shows a simple mail merge style replacement. We'll use this pattern for generating notification messages. The last example is a basic security measure, replacing HTML angle brackets to prevent cross-site scripting. In our platform, we'll use more sophisticated sanitization, but this shows the concept. This slide shows a complete data cleaning pipeline, something you'll implement in your Carbon Track platform. Raw input comes in with extra spaces, inconsistent casing, units attached to numbers, and various formatting issues. Step 1 is always trim everything. Step 2 applies field-specific transformations, proper case for names and locations, remove commas and units from numeric fields, uppercase for serial numbers, lowercase for status codes. The result is clean, consistent data, ready for storage and calculation. This pipeline runs every time data enters our system, whether from a form, a CSV import, or a sensor API. Data quality is the foundation of accurate emission reporting. STR prediction adds characters to make a string a specific length. The default pads the right side with spaces perfect for left-aligned columns. Using STR pad left pads the left side perfect for right-aligning numbers. STR RPT repeats a string a given number of times, great for separator lines. Together they create professional aligned tabular output. Look at this emission summary. Source names are left aligned, numbers are right aligned, and separator lines frame the data. This is exactly what a text-based report should look like. While our platform will eventually use HTML tables and Twig templates, understanding text formatting helps you build CSV exports, log files, and command line tools. Suffix is the Swiss Army knife of string formatting. It takes a format template with placeholders and fills them with values. %S for strings, %D for integers, %F for floats with decimal control, and %% for a literal percent sign. The power is in the format modifiers. %-20s means left aligned, 20 characters wide. %12.2f means right aligned, 12 characters wide, 2 decimal places. %05d means 0 padded to 5 digits. Printf does the same thing but outputs directly instead of returning a string. For our platform, sprintf is ideal for generating log messages, building database-friendly formatted strings, and creating export data. It's more powerful than concatenation for complex formatting. Explode splits a string into an array by a separator. Implode joins an array into a string with a separator. These two functions are the bridge between strings and arrays. For CSV processing, explode a comma-separated line into individual fields. For parsing our reporting period format, 2025-Q2, explode $period gives us the year and quarter separately. Going the other way, implode builds a CSV line from an array of values. We'll use these extensively in our CSV import-export features. Explode is simpler than subster. When the data has consistent delimiters, you don't need to count character positions. Just split on the separator. Here's your cheat sheet. Print this or bookmark it. These are the string functions you'll use constantly in our platform. For cleaning, trim, centroids. For searching, stir contains, stirlen. For extracting, subster, explode. For replacing, stir replace, stir pad. For formatting, sprintf, number format. Each function solves a specific problem, and combining them creates powerful data processing pipelines. You don't need to memorize every parameter, just know what each function does and look up the exact syntax in the PHP manual when needed. Over the next 12 weeks, these functions will become second nature. Here's your cheat sheet. Print this or bookmark it. These are the string functions you'll use constantly in our platform. For cleaning, trim, serializers. For searching, str contains, stirlen. For extracting, subster, explode. For replacing, str replace, str pad. For formatting, sprintf, number format. Each function solves a specific problem, and combining them creates powerful data processing pipelines. You don't need to memorize every parameter, just know what each function does and look up the exact syntax in the PHP manual when needed. Over the next 12 weeks, these functions will become second nature. Excellent work. You now have a complete toolkit for string manipulation. You can clean messy input, standardize formatting, extract data from structured strings, replace bad values, and build professional formatted reports. These skills are the foundation of our platform's reporting layer. Every GHG report, every dashboard metric, every log entry, every CSV export uses these functions. In the next hour, you'll put everything together in a hands-on lab where you'll process raw device data and generate a formatted energy tracking receipt. Let's take a short break and then dive into the lab. Welcome to the lab portion. For the next hour, you'll build something practical. Imagine you're the first developer at Carbon Track, and your task is to create a script that takes raw device data with all its messiness and produces a clean emission report. This exercise tests everything from today, using the right data types, cleaning strings, performing type-safe calculations, and formatting output professionally. I'll walk you through it step by step, and you'll code along. By the end, you'll have a working script that processes real-world style data into an actionable emission report. Let's start coding. Open your editor and create a new file called energyreceipt.php in your week 02 folder. Step 1 is about establishing clean, properly typed data. Every variable has a deliberate type: strings for text, floats for measurements, booleans for flags, constants for values that never change, and null for missing optional data. Notice how I include the unit in the variable name. $daily consumption kilowatt hours tells you both what it is and what unit it's in. The constants define our emission factor and conversion rates. Type everyone's code along with me. Now we simulate what real input looks like. And it's messy. Device names with trailing new lines, locations in mixed case, numbers with commas and units attached, booleans as the string 1, and white space only fields. Everything is a string. That's how data arrives from HTTP forms, CSV files, and APIs. Before we can do any calculations, we need to clean this up. The output shows each field with brackets so you can see the hidden white space and formatting issues. This is a realistic scenario. If you don't handle this correctly, your calculations will be wrong or your program will crash. Step 3 is the cleaning pipeline. Each field gets specific treatment. The device name: trim white space, convert to lowercase, then capitalize each word. This normalizes Envirotech Smart Meter Pro to Envirotech Smart Meter Pro. The numeric value, trim, remove the thousands comma. Result is a clean numeric string. Temperature, trim and remove the unit suffix. Serial number, trim and uppercase. And for empty or white space only fields, we convert to null. Notice we don't change types yet. Everything is still strings. Cleaning and type conversion are separate steps. This keeps the pipeline clear and debuggable. Run this and verify every field is clean before proceeding. Step 4 is validation, checking that the clean data meets our business rules before we do any calculations. We check string lengths, verify numeric values are actually numeric using isNumeric, ensure values are positive where required, and check format patterns like the serial number prefix. Each validation failure adds a message to an $errors array. If any errors exist, we display them and stop execution. This prevent bad data early pattern is fundamental to our platform. In later weeks, we'll encapsulate this in a validator class, but the logic is the same. Notice we use the cleaned data, not the raw input always validate after cleaning. Step 5 is where we cast and calculate. Now that data is clean and validated, we cast each value to its proper type. Notice the Boolean cast. Bool int, we first cast 1 to integer 1, then to Boolean true. Direct bool 1 also works, but the double cast is more explicit. Then we calculate. Daily consumption times the grid emission factor gives daily CO2e in kilograms. Multiply by 30 for monthly, 365 for annual. Divide by 1,000 for tons. We also add a carbon cost estimate using the EU ETS price. This makes the data more meaningful for business users. Every calculation uses our previously defined constants. The numbers flow cleanly from input through calculation to result. Step 6 builds human-readable status strings from our data. We use Booleans for the active-inactive display, conditional logic for temperature assessment, and emission thresholds for severity classification. Notice how null values get a default display string, no notes recorded, instead of showing nothing or showing null. This is user experience design at the data level. Your platform's credibility depends on clear, informative status displays. The icons add visual weight that makes scanning reports easier. When we build the web interface in later weeks, these status strings will become CSS-style badges, but the logic for determining them is the same. Here comes the big payoff. We use Heradoc to create a professional, formatted receipt. All our variables are interpolated directly into the template. The box drawing characters create a visual frame. The sections are clearly labeled with icons. Every value we've cleaned, validated, and calculated is presented in context. This is the template pattern we'll use throughout our platform. Define a layout, embed data, output the result. In later weeks, we'll use Twig templates instead of Heradoc, but the concept is identical. Define structure, inject data, render output. The emissions section combines Heradoc for the header with sprintf-based lines for the numbers. This hybrid approach gives us the best of both worlds. Heradoc for the static frame, sprintf for precisely formatted numbers. Notice how number format is called inside sprintf. We can't put function calls directly in Heradoc interpolation, so we use sprintf for lines that need formatted numbers. The carbon cost line makes emissions tangible for business users. Your emissions cost X euros per year at EU carbon prices. The percentage comparison gives context. Is this device a big emitter or a small one? These contextual insights are what make a reporting platform valuable. The footer completes our receipt with metadata, notes and error status, using our null-safe display strings, generation timestamp, reporting period, and methodology reference. The methodology line is important in GHG reporting. You must state which standard and method you used. We're using GHG protocol scope 2 location-based because we're using the grid average emission factor. The tagline at the bottom adds a professional touch. Put this all together and run it. You should see a beautiful formatted receipt that would not look out of place in a real monitoring application. This is what we'll build toward all semester, but with web interfaces and databases. Let's zoom out and see the complete structure. 7 steps forming a clear pipeline. Define data, receive raw input, clean it, validate it, cast and calculate, determine status, format, and display. This is not just an exercise pattern, it's the architecture of every web application feature. When a user submits an emission entry form in our Carbon Track platform, the data flows through exactly this pipeline. Raw HTTP input, cleaning and sanitization, validation rules, typecasting, emission calculation, database storage, template rendering. Master this pattern now, and the rest of the course becomes variations on the same theme. Now it's your turn. Add a second device with different characteristics. This one is an HVAC controller that's currently inactive. The raw data has different formatting issues. Tabs instead of spaces, the temperature unit is attached without a space, and the device is inactive. Process it through the same pipeline. The interesting challenge is, should you calculate emissions for an inactive device? That's a real business question. For our exercise, still calculate, but mark it clearly as estimated device inactive. Then generate a combined receipt showing both devices with a total. This is the beginning of multi-source emission reporting. Here are some hints to help you. For the temperature, the unit is attached without a space. Replace Celsius degree with empty string. For the kilowatt-hour value, there is both a comma and a space unit to remove. Use an array and string replace to handle both at once. For the inactive device, remember that bool int 0 gives false. Add a note to the receipt indicating that inactive device emissions are estimated. For combined totals, simply add the two devices' emissions. And for the comparison, use a ternary to determine which device is the higher emitter. Take 15 minutes and I'll walk around to help. Look at this preview. Right now you're writing the cleaning code separately for each device that's repetitive. Next week we'll learn functions, and you'll wrap all this cleaning logic into a single reusable function called clean sensor input. Pass in any raw device data, get clean data back. Then you can process 10, 100, or 10,000 devices with the same code. And in week 9, this function becomes a method on a class. And in week 12, it becomes part of a service with an interface. The same logic, increasingly well organized. This is progressive development. Each week we refactor and improve. Let me highlight the most common mistakes I see in this lab. First, calculating before cleaning, if the raw string has commas, the calculation is wrong. Always clean first. Second, casting without validating float, not a number, gives 0.0 silently, which would make an emission entry show 0 instead of flagging an error. Third, The null comparison trap, empty string equals null with loose comparison. Fourth, not handling inactive devices if you only calculate inside an if block. The variable is undefined outside it. Fifth, trying to put function calls inside HarryDoc. It only supports variable interpolation, not function calls. Pre-calculate into a variable, then interpolate. Before you call it done, verify your output against this checklist. Is every field clean? Are numbers formatted properly? Are null fields handled gracefully? Does the severity label match the emission calculation? Test with edge cases too. What if daily kilowatt hour is 0? What if the device is inactive? What if the serial doesn't start with ENV? A robust script handles all these cases. Run your script multiple times with different inputs and make sure it behaves correctly every time. This testing discipline is essential for building reliable software. Your homework extends today's lab to 5 devices. Each has different cleaning challenges. The big twist is device 5. The solar inverter has negative consumption because it generates electricity rather than consuming it. This produces negative CO2e, which is a carbon offset. Your report should show this clearly and subtract it from the total. This is a real GHG accounting concept. On-site renewable energy reduces your Scope 2 footprint. Your final output should show all 5 devices, scope totals, and a net total accounting for the solar offset. Your homework output must have 2 parts. First, individual blocks for each device, like the receipt we built today, but for each device. Second, a summary section with gross emissions, solar offset, and net emissions. The summary should identify the highest emitter and show total carbon cost. Make sure to use all the string functions we learned. This homework is substantial. Start early. It reinforces every concept from today and prepares you for next week, when we'll add conditional logic and custom functions to make this code more elegant. That's a wrap for week 2. Today you mastered PHP's type system and string manipulation in the context of GreenTech data processing. You understand the differences between int, float, string, bool, and null, and why confusing them can lead to wrong emission reports. You can clean messy sensor data, validate it, cast it to proper types, perform calculations, and generate professional formatted output. The pipeline pattern raw input, clean, validate, cast, calculate, format, display is the foundation of every feature in our platform. Your homework extends this to multiple devices with a solar offset. Next week, we'll make this code smarter with conditionals and reusable with functions. Great work today.